So welcome to today's coffee lecture. This is the second week of this, and my name is Leo Betschart from the Chemistry, Biology and Pharmacy Information Center. And today I will give you a quick overview of ChemSpider and what to expect in this database. What is ChemSpider first? You see the URL here. I will give you a demo afterwards. So this is a free database that anybody can access with an internet connection. It has more than 120 million structures from a very broad variety of data sources. And it is based on a crowdsourcing approach. I will show you afterwards also what that means, and includes predicted physicochemical properties. So for a lot of the compounds, it also has experimental values, but not for all, so there is gaps in there. And it's currently owned by the Royal Society of Chemistry, so we hope it will exist for a long time because this seems a solid basis of ownership. And with that, I transition over to the database. So if we go to its website, it looks like this. We have a simple search mask here, but we can also transition and search via structure or do combined queries. And I also want to highlight down here, it says it has 278 data sources. So let's quickly open this in a new tab. And then we can see what these sources are and also how many data points there are from this source and when it was last updated. So we can, for example, see, well, which one has the highest count. Now it, of course, sorts in the wrong way. So Aurora Fine Chemical is responsible for most of the counts. And maybe Campbell is a data source that you might know if you are active in this field. Okay, but let's go back to the initial search mask. I will do a simple search. This is a coffee lecture, so I'm going to search for caffeic acid, which is a component in coffee, but actually in most plants you will find this compound. And so I do a quick search and you see I get 2 hits. One of them is the well-defined one, and then we have here one with a wiggly bond where it's not clear what the stereochemistry is. So I'm going to look at the first entry. We also see that this is the much more prevalent one, so it's found in more databases or more data sources. And I'm going to click on it. Then we get some more information like molecular mass and weight, and we can get additional details here. So for example, a systematic name, because now we just use the trivial name, and here's a SMILES code. I'm just going to copy that because I can use that afterwards, and also INCHI. So I'm going to close that, and then we go further down. We have a list of different names that are used for this compound. And that's why I would also suggest, as in any chemical database, try to search with the structure, because if the name you're looking for is not indexed, then you might not find what you look for. Then what else do we find here? So let's look at the property, and we have different kinds. So we see we have 4 categories of calculated properties, so they are just modeled, but we also have experimental ones, and those are listed first here. So we have spectroscopy, for example, a bunch of experimental melting points, solubility, but here it's only in ethanol. And then already starts the category of predicted physicochemical properties. So in that respect, I have to say it's not very comprehensive, and for how should I say that, for very popular compounds, you might find a lot of information, but for the less trodden path, this might be less valuable. What else can we do? We can get a spectrum, and if we click here on the item, we get actually a carbon NMR spectrum that we can look at. What I also found, so we can look at it here, and there is a source where this material apparently comes from, but if we click on it, it's not active anymore. So it also serves to some degree as a repository for the data that's associated with it. And that is, of course, nice, because if the University of Wisconsin doesn't guarantee long-term storage of this data, that's quite a pity. And then we can also explore some of the literature that's associated with this, and it's sorted generally to links and references. And then because this is owned by the RSC, it preferably also links to its own content and then to PubMed. Now I want to show another aspect. So we can do a structure search, and I could either draw my structure here and then say I want to do a search, or you saw me copying that smile string before. I can use that to create the structure here, and then it draws it nicely for me. And I can choose I want to do a substructure search and quickly perform that search. And then, of course, we get caffeic acid itself, but also related structures. And here I'm just quickly going to sort them by molecular weight. So that takes a second, and now I have to do it again to have it the other way around, because then, of course, my parent compound is at the top of the list. So that is the compound that we looked at. And now we have other ones that are heavier because they contain additional atoms. Peculiarly, now I don't find the compound that I was looking at before, the one that doesn't have the wiggly line here, which I also find a bit confusing. Okay, so this was one of the aspects. We can search for compounds here. Then this I just want to mention in passing. They also have a separate category, CSSP, ChemSpider.com, which is synthetic pages. And that is a place where you can upload your organic synthesis preparation. So let's, for example, look at something like lithiation. And then we have an entry here from 2018, and I click on it. I could, of course, also search by structure here. Then we have the reaction that was done, the chemicals that were used, and then the procedure, some comments relating to safety and other aspects by the author. And finally, we also have NMR and IR data, and even some associated content like a ChemDraw file here that we can import the structure to another place. Okay, I don't want to dwell too much on this because there is also the most recent submission. And if I look at this, so I have the most recent one. So let's go to maybe rank number 5, and then we see that was in 2021. So there is not so much going on here, or there is relatively little content for what this could be potentially. And then I also want to highlight that there is an API for this. So if you are in the field of machine learning and are interested in downloading a lot of compounds and maybe also some of the associated property, but again, be aware that many of them are going to be calculated, but that might still be valuable for certain applications. There is an API where you can get a large amount of data in a programmatic fashion, so via Python script or something. You get 1,000 call or requests for free. And if you need more, then you will have to pay and get in contact with them to be able to use that system. And there's documentation on how to use this exactly. And so now I'm going to jump to the very end of this. That was my quick intro to ChemSpider. Now I'm popping the link to the coffee lecture card, which provides a little summary of what I was talking about into the chat as well. And then what remains is to advertise tomorrow's coffee lecture, which will be by Oliver Wren about Kudos. Kudos is a tool to help you make your science more accessible to maybe also non-scientists or people from other fields, and provide some support with that. And with that, I want to thank you. If you have any questions, feel free to unmute yourself if you're online.